That's part of the context.
Well, and a baseball bat is pretty big.
Right.
So a baseball bat's not something you can carry in your pocket.
So we always have that context, and it can make us see something like that and know it's just wrong. It's ridiculous. And at the same time, we can also understand, I see why you think that is what you think.
3, 2, 1. Welcome to Love Machine.
Welcome back to Nerding Out with That Nerdy Catholic. I am Seth Payne, That Nerdy Catholic, and we're joined again today by my good friend Adam Schroeder, who is in the engineering department at the University of Toledo. Before we jump in, I want to let you know that this episode is brought to you by Nerdy Catholic Tees. There are lots of different designs on shirts, mugs, and other products. When you go to Nerdy Catholic Tees, use the coupon code ThatNerdyCatholic to get 10% off of your order. If you're a Catholic nerd, get something from Nerdy Catholic Tees. Show the world your nerdy Catholic self and wear your faith on your sleeve. Now that we have that out of the way, if you'd like to help this channel, like this video, share it with your friends, click that little subscribe button and that bell to get a notification on whenever we put up a new video. All right, let's jump into it. Welcome back to Nerding Out with That Nerdy Catholic. I am Seth Payne, That Nerdy Catholic, and we have Adam Schroeder with us here again, talking about machine learning and talking about not just how it works, and this is going to be just a kind of rudimentary looking into machine learning. As you know, Adam will admit he is not a programmer, but I was a programmer, but I never got that far as actually doing AI and machine learning. But looking at especially where it interacts with real world objects. That is where Adam has focused mainly on machine learning. And so we're going to talk about that, and especially some of the humorous and beautiful ways that we can look at machine learning and what it means. So welcome back, Adam.
Hi, Seth. Thanks for having me back. I passed the nerd test.
You passed the nerd test, yeah. So last week, go back to last week's episode to learn a little bit about Adam. And how much of a nerd he is. He got an A+++++ on the nerd test. and as nerds, we always want to get as many pluses on the end of our A as possible, right?
Yes.
A few weeks ago, I was able to visit Adam in his lab, and he showed me some of the things he was working on, and one of them was a really interesting application of machine learning. Why don't you tell us about that project?
Sure. I this semester designed and taught a new course called Autonomous Vehicle Technologies. And so one technology is using vision, using cameras, the way that autonomous vehicles do, and they need to be able to recognize that's another car, that's a pedestrian, that's a stop sign. And how can they actually do that? So machine learning and machine vision are some of the things that we talk about. And for one of the great things is now you can basically get this working on your own without that much work. I can write programs, but you don't have to do something from scratch to make this work well. Yeah, so you're able to just press execute, run, and use a webcam and see there's a coffee cup, there's a person, at least with 75% certainty that's a person, and it's great to be able to do that in real time. So software like MATLAB and packages in Python, one called TensorFlow, you can do this with only a little bit of programming effort. When
I went to his lab and he showed me this program, it was interesting to see, the percentage of confidence that this program had and whether something was what it said it was. So, it looked at Adam. I think it said it was an 84% sure that he was a person. Looked at me, and I think it was around 75% sure that I was a person. And behind us, there was a chair, and it was more sure that that chair was a person than I was a person. So I don't know what that, we might want to get into the metaphysics of personhood. But the best was you just hold something up random in front of the camera and see what it says. So I took a pen and I held it up in front of the camera, and it said it was about 90% sure it was a baseball bat. So I think that is so interesting that looking at machine learning, and there's so many assumptions that we make about what is obvious. Talk about that when you look at how machines work. Why can't we make all these assumptions?
One thing that we have that machines will never have, unless we go down this laundry list of a million end cases or edge cases, we have context for everything that we're experiencing. And these machine learning algorithms, they know what we train them on, but they don't necessarily pick up all the context that we get to pair with everything that we do. Like, I know it would be really unusual for my friend Seth to bring a baseball bat, because I have I'd never even talked about baseball with him. That's part of the context.
Well, and a baseball bat is pretty big.
Right.
So a baseball bat's not something you can carry in your pocket.
So we always have that context, and it can make us see something like that and know it's just wrong. It's ridiculous. And at the same time, we can also understand, I see why you think that is what you think. So in some ways, it can't extrapolate from what the information that we feed to it.
Mm-hmm.
So it's hard for us to take all of the assumptions which come from the context that we have and package it in a way that we can train all of that into it. So it's hard for it to extrapolate from what it's been taught. Yeah. And it turns out 1,000 objects is not really that much. And there's always these shades of understanding, like, that's a baseball bat, but I know that it's a kid's bat or a toy bat or a wooden bat or a broken bat, or on and on and on.
Yeah. So when you're working with any sort of program and any sort of machine learning program, you have to teach it everything.
Right. It's there's usually two sets of data. There's the training data, and then you have to withhold some of that and then use some data it's never seen before and try and validate how well it's doing. So you are just determining exactly what it's being trained with. There are also some things called, you can do supervised learning or unsupervised learning. Supervised learning, I might say, here are 10 different types of objects and here's what they are. Figure out how to tell the difference between them. Or unsupervised might be, I'm going to show you 1,000 different things and you figure out how many types you think there are. Mm-hmm. And okay, maybe you're bundling baseball bats and pens together.
One of the things that we were talking about before was this looking at how a machine learns versus how our kids learn. And I realized that this week my younger daughter is in kindergarten and she is in the process of learning how to read. And looking at her sounding out a word, and I especially enjoy watching it as she's looking at a word and she's sounding out completely incorrectly. And she'll keep saying it wrong, like the first syllable, and then the second, like if it's a 3 or 4 syllable word, she'll say the first syllable completely wrong, the second syllable completely wrong, the third syllable completely wrong, and then she'll get to the 4th syllable and she'll say it completely incorrectly, but then she'll realize that, wait a second, this actually sounds similar to another word that I know, and then she'll say, oh, and then she'll read it correctly. Mm-hmm.
almost any example of me learning or some of my kids learning, I can find some similarity to how that's applied when machines are learning too. So for your daughter, that's an iterative process. She has to step through it one time, something she's never seen before, but she can step through it iteratively. And maybe she doesn't even get it the second time. She says it and still mispronouncing a syllable, and then the third time she's able to get it. And you can quantify that and say the first time it was 5% correct, and the second time was 75, and the third time was 95, and you keep trying to march in that direction.
But thinking back, comparing that to what you were saying about the pen and the baseball bat, that there is, and that we have context, and the amount of training that has to go into her learning what that word is so much smaller, so much less than a machine, right?
Or at least it's not formulated in the exact same way. So when you're talking about training machine learning for detecting objects, like we were talking about, you need thousands of images. I need 1,000 images of an apple if I want to be able to recognize an apple. And I think the same thing's happening when we learn. It's just that it's been spread out over every experience we've had since we can remember in our lives. That so first she didn't know what words were. She just could make some sounds, and then she was able to organize sounds. And then she learned her letters, and then she was able to organize them into syllables. So it's progressively building on all of that, but it's based on every relevant experience that she's ever had, without having to organize all of that. Of course, she went to school, and you spend a lot of time teaching and correcting. And
Well, at some point, I'd love to talk to like a neuroscientist, talking about more about how that actually works. But the thing that's amazing, thinking about talking, is that if you are trying to get a program to learn to talk, you have to do every single step. But the amazing thing about people is that that a baby just starts making noises. But you don't have to pick up your baby and say, okay, now I'm going to make this sound, ah. Now you make this sound, ah. It just comes automatically.
Right.
They hear us make sounds, and they make sounds, and then they, as they're putting it together, they just start repeating us.
Yeah, we can think of explicit examples where we're saying that this is the sound, or this is an apple. But aside from those, I don't know what percentage that is, but I bet most of the things they're not learning through us explicitly telling them what it is. They're absorbing it somehow, and they're understanding the context of a positive voice, a negative voice.
Yep.
Yeah.
Well, and thinking about probably maybe one of the examples of a baby learning compared to a machine learning that might be the most similar is, we all have examples of, because every single baby does this. All right, here's something. I'm going to put it in my mouth. Does this belong in my mouth? Yes or no? Oh, here's this thing. I'm going to put this in my mouth. Does this belong in my mouth? Yes or no?
So both a machine and a human are learning by making a lot of mistakes and hopefully learning from them. A machine tries something and it gets 5% success, so it knows that wasn't great. That was the wrong guess. And a human does the same thing. They stick dirt in their mouth and they say, I shouldn't have done that. That was bad. And now I understand. So it's a positive reinforcement when they do something they like or it's a success, or negative reinforcement of, I'm not going to try that again. I got to try something else.
Now, with your understanding of machine learning, does that make any difference in how you look at your kids as they're figuring things out?
Yeah, that's a great question. I have a lot of the same moments. I guess it's more formalizing how I see them learning, showing them positive examples of something, showing them negative examples of something, letting them guess something without me telling them the answer and then telling them if they're right or not, showing them things they've never seen before to see if they can put together two little pieces of knowledge. So it's more helping me see in more detail exactly some of the mechanisms for learning without understanding the neuro side of it at all.
Well, and it gives me such a great appreciation of how God created us, that we can do that we can learn on our own and figure things out. You thinking about that, the puzzle that we all had some version of as a kid, where you just have 5 holes that are 5 different shapes and 5 pieces that are those 5 shapes. And okay, well, let's see, does this go in here? No. It's going here? No. This going here? Okay, that goes in there. And then as you do it, you get, at some point early on, that's so hard. And then after a little while, it's like, oh, this is easy. You put this here, put this.
Yeah, it does give you appreciation for how we can seemingly learn things without 1,000 lines of code. Some equivalent of it. It's I'm sure it's even more complex. But from our point of view, we're just learning. We don't have to think about how we're learning. It's just happening.
Yeah.
So
well, for a lot of machine learning, especially up to recently, you had to have someone watching over the whole process. What about one of the things that's been in the news a lot lately, talking about machine learning, is and I think the statement that as far as I understand is very accurate, but I don't think people really understand what it means when you have a program that is learning something, that is using machine learning, and then they say the people that wrote this program don't even know how it works.
So a lot of times we use the term black box, as in something goes in, something comes out, and we don't understand what's happening in the middle. That's a lot of how some of this artificial intelligence, machine learning, deep neural networks, what's happening. We know what goes in, we know that what comes out and whether it's right or not. But in between, it's just something really complex. And you could follow any single calculation if you want to, but you might not ever get to understand how it's actually working, or putting together some broader understanding of how it's working. So that's pretty amazing. And yeah, it's amazing that we have the computing power to be able to do something like that now, which is new. We have really big chunks of data that we can feed to machine learning models, and it's more than an individual human would be able to do. Like, you picture the romantic image of some researcher somewhere trying something 1,000 times and remembering something from that paper he read 20 years ago and putting it together with something a colleague said in passing last week.
Eureka moment.
And then eating some fruit for lunch, and then it all magically comes together. But expanding that to really remembering the details of everything you've actually learned, it expands a lot of possibilities that way. Not relying on that single absent-minded professor recalling some side conversation he had with someone at a conference 30 years ago. So I think it's really amazing from that point of view, and able to find patterns in really, really big groups of data that just a single person could not. Yeah, I think I've gotten diverted by the topic of machine learning, and I don't know if I remember your question anymore.
Yeah, well,
Seth.
actually, I think that covered it. But I think that the thing that's interesting, we talked about this when I was at your lab, is that when I realized, I remember learning this a year or two ago, that whenever you go to a website and you have to prove that you're a human, the thing that pops up is this picture, and it says, and it's a grid, and I just did it the other day. It says, click every picture that has a bicycle in it. And then another time it was click every picture that has a stoplight in it. And if you think these are just random images that you're trying to pick between, it's not. You're part of this really large machine learning process that you are helping confirm for these machines that are trying to learn how to drive autonomously. You are confirming what is a stoplight and what is a bicycle, because as you said, when you have a machine that is driving a car, they need to know what is another vehicle, what is a bicycle. Have that one line of code: do not run over the bicycle. Yeah, I think that is so interesting that we are now part of this huge machine learning experiment.
Yeah, we generate data with everything that we do. It's just how is someone going to use that data later on. It's interesting too, because you bring up the example of verifying, are you a human or not? Mm-hmm. So if I watch you pass that test, I can teach a machine how to pass that test too. And then another machine has to make a little bit harder test, and which baffles the first machine, but then I can teach it again. So it's just this evolving back and forth of proving that I'm a human when I'm not.
Yeah. Actually, one of the things you told me when I was at your lab, you're talking about trying to write a program to get a robot to actually click the button on that test.
I was able to borrow a FANUC industrial robot, 6-axis robot, and the one thing I really wanted to do, I think I've seen a video somewhere else, is move a mouse with it and click the button that says, "I am not a robot." And I did it, and somehow it knew I was a robot. So I was just ecstatic that I was first able to do it, and then also I don't know if disappointed is the right word. Maybe encouraged. It knew I was a robot, a different kind of robot than it was thinking of. But yeah, I think with a little more work, I could fool it.
So is this the whole machine learning, especially where it comes into the whole autonomous cars, and do you think that is something that we need to worry about?
I put it in the same category of things as like drug-resistant antibiotics that no one has there's obviously a danger there, and we all know the frustration of getting hung up on some computer-related problem, and it just it governs more and more of our life. Like, we just want to talk to a human sometimes, mm-hmm. but first we have to get through the layers and layers.
Yeah, that robotic woman's voice on the phone.
Right. Or that person who's happy to chat with me on this website and help me with my problem. I'm not more worried about it than I am any other technology necessarily. Mm-hmm. It has the same. Any technology can be used for good things or bad things. So it depends on the humans that are using them, mm-hmm. and their morality and how they use them. So I'm also afraid of how someone could use a a 200-pound bowling ball. They could roll it down the street and they could hurt me with it. Just like machine learning could have some negative consequences.
And actually, it's at some point in the future, we'll do another episode on this topic, which I think is really interesting about something we've talked about before, about what does it mean in a school context, in an engineering school, teaching the students morality along with the engineering. And especially, like you're saying, it all depends on who's using it.
Yeah, so especially for engineers who are creating things, you have to form the whole person so that they can create things for good, things that improve the human condition, things that recognize the dignity of people and the inherent value of people.
So then going back to what you were talking about at the beginning, so you're working on some of these projects that involve the autonomous vehicles. What kinds of things have you worked on, and what kinds of things do you hope to work on in the future related to that?
Yeah, a big part of my job, teaching students, I want to make sure that we're teaching students the technologies that they need to know. So for me, it's less on the research side and more making sure we're teaching students the right things so that they can be successful. So they need to understand how things like vision and machine learning works, and then they can apply it to autonomous vehicles and sensors like LiDAR and things like stereo vision, using two cameras and getting some sense of depth with them, or fusing information together from a bunch of different sensors and trying to get one good estimate of something. So for me, it's more the teaching mission of making sure students are able to do those things, and then they'll get a job. And for sure, you'll get a job if you have those skill sets. So I think it's interesting just because I'm curious about everything and I want to understand it myself. But for me, it's more making sure I can teach someone, because those are important things to understand. So I talked before about how machine learning, it knows what we teach it, and it's hard for it to extrapolate beyond that. So it's never been trained on a pen, so it says that's a baseball bat instead. At the same time, a lot of the different artificial intelligence approaches use some kind of randomness, and they can come up with solutions that we never would have thought of before because they're using some kind of randomness. And I think about videos of people that are using AI to play video games like Mario, and they find a solution to get through that whole world by doing this spin jump over and over again. Something that when I was playing those games myself, I don't know if I ever even used a spin jump, because I thought, what's the value of this? So that's kind of a silly example, but they can use randomness to come up with some really beautiful or elegant solutions. I'm not calling the Mario thing beautiful or elegant.
Well, and the thing that's neat about that example, which I think is a very simple way of looking at how machine learning works, is that they just programmed in this is your character. You start here, you want to get here, and here are all the moves you can do. If you if you fall here, or if you hit an enemy, this is where you die. The goal is to get to the end and not die. And this is what you do. So just keep doing it over and over and over and over again until you get to the end. And then if you get to the end, try it again and try and do it faster.
Right. Yeah. You make the goal as clear as you get as far as you can, or you get to the end. If you got further than before, that's good. Maybe you should try more of that. Or maybe try what you did, but do randomly something a little bit different. Some really unique, beautiful solutions can come out of applying that process to all kinds of problems.
Well, and thinking about, they just came out with this announcement from Fermilab a couple of weeks ago about this new discovery that could suggest that the standard model of physics is bigger than we thought, and realizing that that there are the experiments that they run, but the experiments that they run at these big colliders get so much data out of them that I'm trying to remember. I think it was like a terabyte per experiment. That most of the work is that they do there is working on the programs that can go through all of that data and find similarities, find connections, and I'm sure that even that there are lots of examples where they can say, well, I just had this program go through all this data, and it found something we never expected.
That's it's a nice contrast to a Mario example, because there the price of me falling down a cliff or running into a bad guy is nothing, and I collect that data, versus an experiment using some collider, which costs millions and millions of dollars for that single experiment. So the stakes are a little bit higher.
Yeah.
But so there's so much data, it's hard for one person to be able to look at it all and do things we do really well, try and find patterns, but not be overwhelmed by just the sheer amount of data.
But even thinking, CERN is currently offline. I don't know. I can't remember when it went offline. I think it was a year or two ago. So the collider isn't even working, and I think they said it's going to be back up working in the next 6 months or a year or something. But still, they're busy because they have so much data from the experiments they did before that they have to keep going through, and so they're continually refining these machine learning programs that help them find something that they, thinking about the needle in a haystack, it's looking for a needle in a galaxy.
The aspect of artificial intelligence looking for exoplanets is really interesting too. We look for these different characteristics, and how many millions of objects are there that we could take a look at, and so another way that it's kind of beyond what an individual human could do.
Well, and as he said, they sometimes find something, or they'll find something, or they'll find it in a certain way that we never even imagined. And it's actually it's akin to looking at your kid figuring something out, and that awe, they figured it out. and if it's something, and if it's a program that you've worked on, there's also that sense of pride that you have when your kid figures something out. It's like, oh, good job.
Yeah, there's the product and the process. So them going through the learning process and figuring it out, both of those things are there's value in both of those things, I guess.
Yeah. Well, and I think that it's the same. It's the same. I have to think that God has the same kind of experience looking down at us as we figure things out. It's like, oh, it took you a long time to get there, but you did it.
That's one reason it's good to go through the stages of life first, where you're a kid and you're learning all those experiments about not sticking your thumb in the socket, finger in the socket. Then viewing those things as an adult and saying, "Oh, I remember that lesson. Shouldn't do that." But it gives you the perspective that someone knows a lot more than what I do, and sees me make all these mistakes and struggle with the same mistakes over and over and over again.
Yeah.
So being a parent and going through that process, it makes you appreciate that. There's something higher than just yourself.
Yeah. Well, I want to thank you again for joining me today, Adam. It's been an interesting conversation, and I'm looking forward to having you back and having a lot more conversations about engineering, about machines, but especially where they interact with us and how you look at engineering to interpret our world and especially our faith.
That sounds great, Seth.
Be sure to come back next week. We'll be joined by Brent Robbins, who's a professor of psychology at Point Park University in Pittsburgh. He'll be talking about how he got into psychology, the role that joy played in his research, and a little bit about how his faith has played a big part in his research and the work that he does. Thank you for joining us again on Nerding Out with That Nerdy Catholic. As I said before, this episode is brought to you by Nerdy Catholic Tees. Head on over to nerdykatholictees.com and check out all the great Nerdy Catholic merch they have over there. If you use the coupon code ThatNerdyCatholic, you will get 10% off of your order. So head on over to nerdykatholictees.com, get some Nerdy Catholic merch for yourself, and wear your faith on your sleeve. If you like this video, hit that like button, share it with your friends so we can get it out in front of more people. Hit that subscribe button and that bell to get a notification on whenever we put up a new video. I want to thank you again for joining us. I'll see you again next week. God bless.
System shut down.